Hi, and welcome to my new series on AWS Amplify serverless stack. I received a lot of requests to create an end-to-end application using AWS CDK, and I decided that I would start a new series where we will do just that. I first want to create one video, but honestly I didn't have time to create such a long video, so I'll be doing it in parts, and our goal will be to deploy an Amplify website and create CDK TypeScript backend that will be fueling and powering our application. So what will be the goal of this video? On the agenda, we will deploy an Amplify hosted website with serverless backend, and in this video we will be deploying 3 stacks. So first we'll deploy an Amplify stack, and this Amplify stack will take a GitHub repository and then deploy the Next.js website that's in there onto AWS. And so just to underline, I am using Next.js 13, so the configuration will probably work for Next.js 12 as well. But if you're using a different framework, please note that you will need to change your configuration a little. Then for the storage stack, I will be deploying an S3 bucket and 2 DynamoDB tables. And we'll also add some additional secondary indexes and sorting keys just to make retrieving information a little easier. And nothing fancy there, but we'll be encrypting our data with KMS. And finally, we will create also a Cognito stack. And in the Cognito stack, we will allow users to log in with a username and password. And we will also add login with Google and Facebook. I won't be covering creating the APIs at both Facebook and Google, but I will add a link to the AWS description how to do it, and they are very elaborate in it. Every step is described, so I'm sure you will you will be fine. Then let's have a look at the greater concept, because we'll be deploying 3 stacks, but what are we creating in the end? So if we have a look at the greater picture, which is this is somewhat what we will be creating. It might change a little. I quickly drew it up just to have an idea of what we will be creating. So we will be creating in this video the webshop part, so the Amplify, and I already have my domain in Route 53. If you don't have that, so you will have to see how to route it through, because I am using the Route 53 domain and cloud distribution, and we will also create the Cognito user, and we will also be creating the bucket, the DynamoDB tables, and the rest we will create later. And we will be adding metrics, but we won't create a dashboard and alarms yet. So this post sign up trigger will also create, and that will, after we sign up, it will create an entry in the bucket, and it will also create an entry in the customers table. So that's what we'll be creating, and in this video we will be creating only part of it, so this part, and in later videos we will go on with the rest. So now that we have the greater picture, and more will come later of course, let's start with Amplify. So I created a new stack and I called it AWS Amplify, and I haven't done anything to it yet, just created it. And if you don't know how to create it, I have a video on how to create CDK stacks, so you can go watch that and then come back. But for now, I have a new stack. I haven't done anything to it yet, but I will be installing our dependencies, and that will be some dependencies, and most of them are my preference and you don't need them, but this is the list, and I will add it in the video description as well. But the most important one is add AWS CDK / AWS Amplify Alpha, as that's the one that we'll be using. And besides that, I'm adding some extra things like ESLint, and I'm also adding the Airbnb base configuration. It's just something that I'm used to and really like, and that's why I'm adding it. So you don't need to add it. It's just something I like. I'm also adding CDK neg, and CDK neg is an dependency that you can add, and it will scan your CDK stack and alert you on any vulnerabilities related to security. And you need to then acknowledge that you have these vulnerabilities before you can deploy. It's also something that I really like. So I'll be installing all these dependencies now. And while we are doing that, I will also be adding a couple configuration files and making some changes. So I will be adding this. And what this does is it causes the TypeScript generation. So when we are converting our TypeScript to JavaScript, it will go into the dist folder instead of spreading into each folder. So our dependencies are done, and I do have to add some additional configuration files. I always like to remove the jest file, and I'll add a TypeScript version of it. And these are just some configuration that I use, so I'm going for 80% coverage. Most of the time I get 100%, but 80% should be the minimum that I'm used to working over the years. Then let's also add configuration for ESLint. And for that one, we need to have a file called .eslint rc. And here we are extending the RBMB TypeScript, as you can also do this for Next.js and other stuff. So, but for now, I will be using the RBMB base as I'm used to that one, and I have some additional configuration and the jest version. So this will just go through our code, and well, it will give us red squiggly lines and errors if the code is not in a particular way. So for example, we cannot have more complexity than 3, depth and so on. And you can disable this, but I just like to have this so it reminds me if I'm, for example, have too much complexity or my files are too big. So that's the function of ESLint. And again, you don't need to install that, but I just like to have it. So if you're going to use ESLint, we also need an ESLint ignore. And here we will just ignore these files from linting. Then we have our jest, we have ESLint. We also need to adjust a couple things in the git ignore. And I'll be uploading a version of this into my GitHub repo. So you don't need to look at the screen like crazy and write it up. You can just look it up in the GitHub repo. So that's why I'm not going through every entry that I have here, but it will ignore those files. So that's what it does. Then, like usually, I always create a couple files before I get started. So first I will create types.ts, and I will also create config.ts, and the types will just contain all my stack props in this case. So stack props that I will be entering into my template, and these are the values that I can add in the config. So if you have multiple stacks or you want to change something really quick, you can do it in the config file instead of going through the lib and searching through everything. So this is just the easy way to have all your configuration at one spot. So what will be our stack props in this case? I will be creating a new role, and that role will have a role name. So it will be as a type string. It will have a description, and we also use a secret. And the secret we will be using here is the GitHub token. And we've also done this in a previous video. So if you don't know how to do it, just go watch the video where we use GitHub Actions to deploy it. There we also create a GitHub token. And next we will have our app name. So how will our Amplify app be called? And the description. Next three are related to GitHub. So we will have the GitHub owner. What's the name of the GitHub owner repository? Then the name of the repository itself, and which branch do we want to deploy. So those are the types. We'll be saving them. And in the config, I will copy something in. And the current project that I'm using this for is called print helix. So just to illustrate also in this video, I will be using that as an example. So these are the values that I'll be using in this video. So we have a role name, a description, a secret name that you've seen before is like my GitHub secret. We'll use the app name, description, and so on. So these are our stack configs and our types. Then next is to adjust the lib, and in the lib we put all our services that we're gonna use. So the bin is more for configuration, and we need to adjust this as well. So we are importing our config from here, and we are injecting it into our Amplify stack. So now if we go into the lib, it will have all the values that we have filled in here. So, and what I always like to do as well is change the name here. So I will be calling this print helix amplify stack. And let's say you want to have a different stack with a different configuration, but with the same structure and infrastructure as this. You can just change this one. For example, I don't have another config, but let's say you did have another config. You can just change this name here, so stack 2. And now if you do CDK deploy and then this, it will only deploy the second one. But we don't need that. We just need a single stack for now. So then back to the lib, and in the lib we're gonna need a couple things. So I will copy and paste all the dependencies that we need. So what are we importing? These were the already imported ones. And then what we'll be importing is IAM, as we'll be creating an IAM role for the Amplify app. We'll be importing Amplify from the AWS Amplify Alpha. We will also be importing code build, as we will have some build settings for the building of the Next.js 13 app. Then the secrets manager to retrieve our GitHub token that we will pass on. And then I will use some AWS custom resources to do a couple things, like setting the framework and the platform after that we've deployed it. And the reason that I'm using AWS custom resources is that you cannot configure that when you are deploying. So it means that you would have to log in and do it in the console, or you can do it afterwards with custom resources. So that's why we are importing them as well. We are importing the types that we have created in the bin folder, so that we know what to expect and where to expect it. And we do need to use this. So instead of having maybe props, we will definitely have props of this type. Then we will be also importing CFN app from Amplify, and that is mostly to do our domain. And eventually we will also use neck suppressions. And neck suppressions, like I said, neck will be scanning our cloud formation template, and it will give us some warnings. And we do have some warnings in this case, and I will be suppressing them, so you can also see how we do that. And if you don't want to suppress anything, then you should solve them first. But let's start with the first thing, and that is the role. So to deploy it, we do need a role. So I created this role. Oh, yeah. So I'm creating a role, and then the role will get the role name from the props. It will get the description from the props. It will be assumed by Amplify AWS. And then I am attaching AWS managed role, and this is the administrator access for Amplify. So it will create a role with all the permissions for creating everything related to Amplify. You can always narrow this down. This is also one of the CDK Next, but for now I will be using this, as this is the easiest and fastest way for me. And then we will be importing our GitHub token. And how we do that is we use secrets manager, secret name version 2, and then we just pass in the secret name from the props. So if you change it, you can change it in the config file. And we also grant this role access to read it, as it will need the role, it will need to read the token to be able to access GitHub. And once we have accessed GitHub and we are able to pull the stack from there, we also need to build it. So to build it, I have a build config, and this build config, once again, it's a build config for Next.js 13. So if you are using, and also one thing to mention is for Next.js 13 with SSR. So if you're using a static page, you would need to change the base directory. Then you also need to add a command to your npm build that it exports it, and then out will be the folder. But we are using SSR in this example, so that means that in this example we also need to go to next. So this is our build script. It will just use for front end the phase. It will install our dependencies. It will build our Next.js application. Then we are telling it where it can find the output, and we will cache the node modules just to not every time download them. So we have a build spec, and now that we have a build spec, let's also add the Amplify app itself. And so we will create a new Amplify app, and in my case it's Sprint Helix, so we will get an app name, we will get an app description. We'll also use the role that we created earlier to deploy this Amplify website, and then we say the source provider, and in my case I will be using GitHub, but if you're using a different source provider, for example Code Commit or GitLab, Gitbucket, you can just change this source provider and it will use the different source provider to get it. Then also auto creation, I have it on true, and on the patterns I have added the git branch, which in my case is main. And I will add the build specs here, and auto branch detection, yeah, I have it on true, you don't have to do it, but you do need to have the build specs. So the build specs are these ones that we are adding to the Amplify stack, which means that whenever we make a push now to the repository, this will be looking at the repository with webhooks, and then every change will trigger a new build. So do note that if you add your branch here, every time that you push to this branch in your GitHub repository, it will trigger the webhook to create a new build, and it will attempt to deploy the website to Amplify. So that's also why we are not going to add different pipeline or anything to deploy it now. We will just create this, and it will create a webhook to our repository. Then if you are using a static website, you can add this line to it, but as we are not using this, I will remove it. But it is something for if you are using Next as a static website. Then I'm gonna do a couple things, because instead of a static one, we'll have the dynamic app. So we're gonna put the platform on web compute, and I think this is not working. So at least when I tried, it was not working. So we will do it in a different way as well. But we do need to add it, add a branch to it, and the branch we will add stage production to it, so that it will know that this is our production branch. We're also adding the git branch again here, and auto build true. So now that we have our branch, we will now add, and this is also optional, we will add a custom domain. So I'm adding an Amplify add domain, and I'm just adding my app name. So if we go to our config, app name is my website, so printhelix.com. And then we will add the root, and we will add the www, so that it knows to add the DNS records, so that it will route them both to my website. So this will create also a CloudFront distribution. And if you're gonna do this, you do need to create a certificate, and that certificate, well, you don't need to do it yet, but we will create a certificate later. Because we will need it also to authenticate our website, also for Cognito. And if you want to use your custom domain, you need to have a certificate, and it needs to be in US East 1. So do note, you need a certificate in US East 1 to have to use a custom domain. Okay, we've added a domain, and now a couple things remaining. So like I said, we need to add web compute to it, and we also need to update the framework to be Next.js SSR. These are two things that I haven't managed to set in the settings here, and I couldn't find it in the documentation either. So that's why I have created two custom resources, and what it will do, it will just create will run the CLI command. You can also do it in the CLI, of course, but I just like to do it in one stack. It will do it for the Amplify service, and it will call the action update app. And then I will just change on the Amplify app ID, I will change the platform to web compute. And next, I will create another action that will use the Amplify service. This time I will update the branch, and I will add the framework Next.js SSR. So I add the dependency also on the creation of the domain, because once these get started and there is no domain, it will of course fail. So this is the first part. If we deploy this, which in my case, oh wait, I'm of course forgetting something. So we have this one, I removed it because, well, it wasn't working for me, but it should be working like this. But like I said again, I didn't get it to work, so I will be removing this for now. And we don't need to install that either. If we want to deploy this right now and we would run a CDK neg, then we would get an error. So CDK synth is the command to run if you want to check your CDK neg. And if we wait for a second, it will compile it, but just to be sure, I will create a new test. Let me see. So this is a CDK neg test, and what I will do is I will input the stack into this, and I will just expect that there are no suppressed warnings and there are no suppressed errors. So you can also remove the warnings one and only look at errors. I like to also just know that if there are warnings, I want to know which warnings I am actually ignoring. So I will save this and now run npm run test. And npm run test will run all the jest tests that are in this file. And currently there's no test here, but we do have a test here. So let's see what the results will be. And we are getting an error as we have some unsuppressed warnings for neg. And how do we address these? Well, I will show one way. And of course there are other ways to do this, but just to do it very quickly. So these are the errors that we have. So we have an error AWS solution IAM4 that we are using an AWS managed policy. This is not wrong, but you should always do the least privileged and create your roles and and IAM roles yourself and the policies attached to it. We're also using a wildcard in the IAM policy, and this is also one of the reasons why you, if you're using least privileged, you should create the role yourself. But now I will skip that. And finally, we are getting 2 errors, and these are related to the custom resources, as they are using a different node version than my application. And well, I will suppress those because I don't care which node they run, as long as they run the commands they have to do. So if we save this and then again run a test, we should have the test now succeed. Okay, so we have a stack for Amplify, and once we deploy this, this will create Amplify application in our AWS account. It will pull the application, the Next.js application in this case, from the GitHub repository, and it will build it and deploy it. And it will also attach our custom domain to it. Like I said, you do have to have a custom domain in Route 53 to have this work. And the configuration that I'm using are for the Next.js 13 dynamic app. So if you're using a static app, the configuration will be different. Also, if you're using, for example, Next.js 10, it will be different. Keep that in mind. And besides that, if you deploy this, it will not immediately build your website. So after it's successfully deployed, you will have to do a push to your repository. As soon as you do this push, a new build will start in Amplify, and we will be able to see the website getting built and deployed. If you have errors that will fail, you can go to the console and look in the build just to see if it was successful or not. And well, that's this part for the video then. And we're gonna go up to the next. But before we do that, I will quickly go to my deployed version to show you how it will look. So I logged into the console to my AWS Amplify app, and my app has already built successfully and deployed. And I'll have a look at it in a second. But if yours fails, probably in the build step, you can press on the build step and just click them open. And here you can see what exactly went wrong, or if it went in the back end. But currently we're not using that yet, so that should not fail. So another thing that we can do is add access control to it. As I'm still working on this project, I put a password restriction on it. So if we go to this website, I need to enter a password to get in. But as you can see, my Next.js application has been deployed. It's also functioning, so it will render this. So as you can see, it is working currently, and I can navigate on the website. So if we go back to our application, if you just deployed your app and it's still building, but you cannot find it on the domain that you're expecting, just go to your domain settings and check that this is already unavailable. If it's not unavailable, it can take a couple hours. So just wait until this is unavailable, and you should be able to go to your domain. So that covers our Amplify app. We've deployed it into our environment, and you should be able to reach it. And once again, I put the access control here through the console later on, because at first I just had it open. You can also do it in the stack. I just didn't cover it currently, but know that you can add a password to it. So now we have the website running. Next, we're gonna create the storage stack. And in the storage stack, like I said, we're gonna create 2 DynamoDB tables and an S3 bucket. So let's close this off and switch over to our new stack where we create the storage. So I created another stack, and this time I called it AWS Storage. And I will again start with first installing the dependencies. And it's also another list. I will also add this, of course, in the GitHub. So I will install these dependencies. And while it's installing, I will start adding some additional files and configurations. So it will be just the same as I did earlier in the last stack. I will have ESLint, ignore, and also jest. We'll replace the one that's there. So this everything the same as configuration. And then we create a new file, config, and we will create another file, types. So what will be the stack props this time? I'll copy them in again. So it's a little different than last time. I got 2 extra interfaces here. I got secondary indexes, and I also have an interface for the table. And the stack props itself that extend the stack props that CDK gives us will contain KMS key. So we will be creating KMS key to encrypt our data at rest. So KMS can also have an alias. Then it's just an easier way to get the key than having the ARN every time. So we will add an alias to it, and we will add a description. KMS does not have a key name, so we don't need to do that. Then we will be adding an S3 bucket, and the S3 bucket will have a name as well. And finally, we'll have 2 DynamoDB tables. One is a customer table, and one is an orders table. And both of them will be of the type table, so they will have a name, a partition key, a sorting key, and a secondary index. And the secondary indexes can be an array, so it can have multiple secondary indexes of index name, a partition key, and a sorting key. And just to quickly cover what is a partition key, what is a sorting key, and what is a secondary index. The name, well, the name of the table, of course. The partition key will be the key on which we will find data that's stored in the DynamoDB table. So in our case, the partition key is the key that we can search on. Then the sorting key will enable us to sort the data that we are searching with the sorting key. So let's say that the sorting key is a date, then we can sort them on, for example, latest or newest, or any way that you want to sort it. And secondary indexes are extra indexes we are adding to the table, and these indexes enable us to search the data with different partition keys and sorting keys. And we will be adding a couple, and later on we will have more on that. But for now, we are adding these types. So then let's go to the config, and in the config, I'm gonna put all the config. So let's go through it. So I will add an alias, and when you're adding an alias, you need to append alias /, and I will be, just as illustration, I kept everything simple. So these are the things that we will do. We will create a customers table, and our partition key will be an account ID. Then we will have a sorting key that will be account name, and next we will have a couple secondary indexes. Well, on the customer table, we will have one secondary index, which is an email, and the partition key is the email, of course, with the sorting key, the account ID. You can also do something else, but I just want to make sure that I find the, for example, if the account name changes, that case, but I don't know. I was looking for a way to easily do it. And in the orders table, it's a bit different, because customers, I thought you search on account ID or you search on an account name. You might search on an email, but when searching in an orders table, I think you could search on an account ID, you could search on an order ID, you could sort on the date, of course, or on a shipment date. So I have a couple of extra indexes here because I thought in an orders table you might want to search on extra values, but be free to add any values that you want yourself. This is just a simple example of how to do it. So these are the values that we will be passing into our stack. So let's open the lib and import the types that we will be using. And of course, we also need to add them here. Stack config. Okay, now so we have injected our values here into our stack and it's ready to use. So what are we gonna use this time? It's a bit shorter list, so we don't need SQS. We're gonna use KMS, we're gonna use S3, and we're gonna use DynamoDB. So a bit more simpler this time. And of course, we also need to import Next.js as we have installed that. So let's go through everything one by one and we'll go create everything that we need. So first I'm gonna create the KMS key, and a couple things to note here. I'm first creating only a key, and you cannot create the alias immediately on it. It will not show up. So first create a KMS key. I'm adding a description, enabling key rotation, and I have the removal policy on destroy. This means that when I destroy the stack, it will destroy the key as well. By default, it will retain it, and after destroying it, it will remain active for 7 days. So just something to keep in mind. If you don't want to destroy it, change this, but as this is a demo, it will be destroyed afterwards. Then next we're gonna add an alias, and that's really easy as well. We're just gonna create a new KMS alias, and we are adding the key, and then we are adding the alias that we had as the config. So in this case, it will be alias key, alias /ph key. Then for the bucket, I'm gonna create a simple bucket. We have a bucket name. We're gonna use the KMS key to encrypt our data, and we're adding the key here. We're using a versioned one. That means that if someone extra uploads the exact same file, it will just make a new version and keep track of the previous versions of it or file. So I'm adding server access to access logs, and I'm enforcing SSL. You don't have to do this, but I'm just doing it because I want it to use SSL when it is trying to upload or get something from the bucket. And as well here, I am again giving it a destroy policy, meaning that if I remove this stack, it will also remove the bucket. Then next is the first table. Let's create the first table. So I'm gonna quickly go over the settings that I have here. The customers table, it will add a construct name, then a table name. It will come out of the stack props. We have a partition key. As I said, this is the key that we mainly search our data on. And I also get it out of the stack props, and we add the attribute to it. So you can say it's a string, but you also have binary or number, as you can see. And it's one thing that I like about TypeScript is that you have the IntelliSense, but we are using a string. Then for the sorting key, we are also using a string, and we're getting it out of the sorting key. Then billing mode, I have it on pay per request because I'm just going to use a couple things, but you can have it on all the time. It will cost you, of course, some more. And again, we are using our encryption key to encrypt our customers' database. And normally, I think you would have probably a different KMS key to encrypt your data here and there, but I'm just showing you how to create one key and just copy and paste and you have a second key. So I will use that key here as well. Then I'm gonna add the props that I had to, so I'm adding the secondary keys. I need to import this as well. So this is a type that was in the types here. That's why it's getting exported. And what this will do, it will just map over the secondary indexes in the config file. And here we only have one, so it will just create one. But if you want to add multiple, then you could add multiple and it will add them one by one. Do note that it's all type string, so if you're using different values, you would have to change that. And well, the orders table is pretty much the same, so won't go too long over it. But again, we have a partition key, a sorting key, and these settings are the same. And maybe you also want a different key here, maybe not. For now, I will use the same. And with the same function, I will again go over all of the, one second. And this is so ESLint at work saying that my file is too big as I'm over 100 lines, but I will ignore it for the entire file. But again, I'm mapping over the secondary indexes and I'm just adding it to the orders table. And because I'm using string values, they're all at strings. So that is part one. And I will already add all the CFN next. In our case, that is one. There's no point of time recovery. I don't need this at this point, but if you do go into production and you have, for example, a customers table or you have an orders table, most probably you do want some kind of point in time recovery. For example, your database goes down. At least you can retrieve what you had maybe an hour ago. So that is something in production. Don't disable point in time recovery. It does cost a little bit extra, but it surely is worth it. So that is the stack so far. And if we go into the config, once again, these are just indexes that I made up myself, same as the partition keys and the sorting keys. You can name the keys however you want, and it would just be values inside of the table. And let's go back here. So we have the configuration, we have the infrastructure, but this time let's add something extra, because let's add the CDK nag test. So that's the test to see if we have any errors. But this time let's also add some extra tests. So what I'm gonna do is just copy this in. So we are importing a couple things. We are importing CDK lib, we are importing the template for CDK lib assertions, and we are getting the stack out of the lib, and we are getting our config. So I'm just going to quickly show how to test if the stack is actually creating these things in the template. So this is the way that you use Jest, is test, and then, well, what are we testing? We are testing KMS key created, and then inside of the template, which is our cloud, so our cloud formation template, we are searching for the property AWS KMS key, and we're expecting the description that was in our stack config. So this is a really nice way to check if your template resembles the config that you are passing through. I will do this as well for the alias. And as you can see, AWS KMS key, but this time we're using an alias. So we're expecting alias name with our stack config. Next, let's add a test to see if our S3 bucket is there. And for our S3 bucket, this is the configuration. So in the template, we expect AWS S3 bucket. With our name from the bucket, we expect bucket encryption set to KMS. We expect versioning to be enabled. We expect access control, log write, and well, that's it. And then finally, the two DynamoDB tables will be pretty much the same, but let's go through those as well. So what I'm doing here is one of the tables, and this is the second table, but they're pretty much the same, so let's go through it. So we are expecting an AWS DynamoDB table, and it will have the table name with the stack config name that we gave it. And do note that, for example, table name is with a capital T, as well as billing mode, and in the lib they are camel cased, but here they all have capitals, so that's something to note. And yeah, besides that, I'm just expecting all the attributes that I'm giving it. For example, this is the primary keys, sorting keys, the secondary sorting keys, the keys schema, all of these things, and exactly the same test we have for the DynamoDB orders table. And this way, what you can do is just check if everything that you have in your config is also present in your CloudFormation template that you're going to deploy eventually. So let's save this. Then let's see if it actually runs. npm run. Oh, before I'm gonna do that, I'm gonna go to my package JSON, and I'm gonna add a couple extra comments here. So 1 second. To the script, I'm gonna add some extra. So I'm gonna add lint, and what lint does is it checks our file for ESLint errors. So these are maybe syntactical errors, and in our case we're using Airbnb base for TypeScript, so it will check if our code is according to the ESLint config that we've added. This one is not really important right now, but I'm also adding a diff and deploy, so you can add npm, so you can run npm deploy or npm diff instead of CDK diff and CDK deploy. And I add extra command to test a single file, so you can add jest and then add the file that you want to test, and it will only test one file instead of multiples. But for now, just let's run npm run lint to see if we have any syntactical errors. Doesn't seem to be. Then let's run npm run test, and what this will do, it will run both of these files. So it will check our template for the resources, but it will also check our file for neg suppressions and neg errors. And we see that we had 2 suites, they all passed, and total of 7 tests. So that looks good as well. So now we're gonna deploy this as well. Just gonna run npm run deploy, and that will deploy this stack into our environment. And before you deploy, of course, we have to, well, you don't have to, but if you want to deploy it with npm deploy, you also have to change it here to represent the stack name that you actually have here. So do note that this contains the stack name. If you want to deploy it like that, just change it here so it resembles the same stack name that you have here. Okay, now that we have that, let's go on to the Cognito stack, and with that the last stack that we will deploy, but also the most extensive stack. So let's get started there. So I created another stack called AWS Cognito, and in this stack we will create the Cognito user pool and identity pool, as well as the Google login and the Facebook login possibilities for our users. And we will integrate this later with our application, but for now we'll create the Cognito user pool, identity pool, and we'll also enable that when a user signs in, well, first signs up, of course. After sign up, a Lambda will trigger, and the Lambda will then create a directory in the S3 bucket, as well as an entry in the customers table. So let's get started. And again, I'm gonna install a lot of dependencies, and now we have a bit more than previously, but we'll get to each of these when we get to it. So let's again, 1 second, I will make a couple adjustments. Adding the dist folder, then I'm adding a jest config, I'm adding ESLint config, adding an ESLint ignore, and I also adjust the git ignore, and I think that's the start. Then let's create the config file and the types file. So for the types, what are we going to use this time? It's a bit more than the previous one, so let's go through it. So we're again importing the stack props and extending it, and there's a couple things that we will import into our stack and a couple things that we will create. So what we will be importing? The bucket that we just created. So we need the bucket ARN out of the console. Just go to the console, to the buckets, and you should find an ARN. We need the table ARN. We need the KMS ARN. You can also use the alias, because you can use it, it's easier. Then we will need Google secret and a Facebook secret, and the secrets in my case contain an ID and a client secret. And like I said, I will add the video in the video description. I will add a link to how to create the APIs so you can add and gain your client secrets. Next, as I mentioned before, we do need a certificate, and the certificate needs to be in US East 1 for your domain. So you need to create one. I created one for my domain and also for *.mydomain. This allows me to create, for example, www, but also in my case, what we're going to do in the demo is out.printhelix.com. And once it is created, you do need to check that you're in your Route 52 hosted zone, in your DNS settings, that the A record of the *your domain name is pointing to the exact same CloudFront distribution as your A record for your domain name created by the Amplify app. So if that is not the case, you should change the value so that they are exactly the same. And then the hosted zone ID, you can get this out of Route 53. Those are the imports. So these should already exist. And then what are we going to create in the stack? Well, the domain should already exist as well, but we do need the name. Then the Cognito domain will be a subdomain of our main domain. So in my case, I will use auth, so it will be auth.printhelix.com, but you can use something else if you want. We will create a user pool to keep track of our users. We'll create a lambda with which is a sign-up trigger. It will have a name. We will create a user pool client, and that will handle the logins and stuff. But we'll also create the identity pool, and identity pool we create because we want people to log in with Facebook or Google, and that will be identity pool. We'll also link it to the user pool so that people actually create an account, because you do need to know that if you are using, for example, Facebook login or Google login, when they are authenticated in a user pool, by default they are not a user, so they are just authenticated by a federated login. But if you do want to make them users, we will do that as well. Then we create two roles. We'll create the authenticated user role and unauthenticated user role. We'll not really use them yet, but we'll just create them. And then we will create an email, and this is an email for the confirmation email. After someone signs up, we want to send them an email, and callback URLs, login URLs, and redirect URLs. These are all URLs that we will pass into Cognito. Callback URLs are the URLs that you are able to redirect to after, for example, you log in. Then we have the login URLs and we have the redirect URLs. And logout URLs is where you can log out to, and the redirect URL itself is just well, where we're gonna go after logging in. So in my case, I wanna go to my website, and that's what I will be doing. Let's have a look. So we have all these here. Then I will copy and paste, and as this is all dummy information, I don't have the ALNs here, so you should put your ALNs and stuff here. This is all dummy information, but in the demo, I don't want to show all the sensitive information, so I often replace it with dummy holders. So I have the values here as well as some names. I am going to use these redirect URLs just to show it in the demo later, but so these are the values. But based on the types, you should be able to define your own values. And so do note that these have to come out of your own account. So I will save this for now. Then we have types and we have the configs. Let's go to the lib. So I will import those. Then let's import all the services that we will be using. I will this time make a bit of a distinguishment because there are a couple. Like this. So what are we going to use? We're going to use Cognito, we're going to use DynamoDB, we're going to use IAM, we're going to use KMS, Lambda, and Node.js because we do have dependencies, and that way we can package the dependencies. S3, Secrets Manager, Certificate Manager, Route 53, and also Route 53 targets. And I will go through them when we create the resources, why we are using them. So like I said, we are importing a couple things, and that is the bucket, the table, and the key, and we just do from ARN, from ARN, and from ARN. We refer to the stack and a construct name, and then we pass in the ARN from our config file. Then I'm gonna create a lambda, and this lambda, as I said, it will be a trigger that is triggered after a user is signing up. So after the sign up is completed, this will run, and well, we have a name, and I am saying that the file that we need is in this location. Of course, it's not there yet, but it will be there, and we are minifying the file as well when we are bundling it, the runtime that we're using, and the maximum timeout of 2 minutes, and you can adjust this to what you want, but 2 minutes is a bit long maybe, but then we are putting in the environment variables the bucket name and the table name, as we will need them to know which bucket we need to target to create a directory and which table we need to make an entry in. And finally, I add some log retention to it for 2 months, meaning that after 2 months, the CloudFormation logs that this Lambda creates will be deleted. And by default, they're indefinitely kept. So if you don't want to have them forever, then you should add a log retention. What I'm also gonna do is quickly touch on CloudFormation, and that's why I'm adding another policy which will allow us to put metric data into all resources. And I don't have a metric yet, it will be created after this one runs. So that's why I'm saying all resources, but in general, you should maybe create the metric first and then just give it on that resource the permissions. Then I'm gonna add another couple of permissions. So For the Lambda, I will add to the role policy the CloudWatch policy. I will grant it the KMS key encrypt data. I will also grant it the bucket grant write, and I will grant it the table read write data. And this is encrypt and decrypt for the KMS key. So the Lambda will be able to write to both the bucket and the table and choose the KMS key. Now will come a really big part, and that is the Cognito user pool itself. So let's have a look at the user pool. So the Cognito user pool, we created by doing new Cognito user pool, and we need a couple things. So we have a user pool name, and we get it out of our config. We enable users to self-sign up, meaning they will be able to press the sign up button and sign up, else only the administrator will be able to add new users. Then we check the attributes that we want, if it is required or not. If it is not required, it will also not be asked when a user is signing up. So if you want it to be there when a user is signing up, you should put it on true, but you can also add these things later or change them. I'm also adding extra things for company name and I don't know, just extra attributes. In my use case, it will be giving companies the possibility to add their VAT number and company name and things like that. I'll enable users to sign in with their email and username. You can also restrict it, and I'll auto verify the email. So I'll put it also on true, or else you have to verify the email as well. And user verification will be done by an email link, and you can also change this to code, and then it will be a SMS. Well, it will be a code in the email, but you can also do an SMS instead of an email. But I like the idea of a link that you need to press. So after someone signs in, you will get an email with the subject and a body saying, hey, welcome to the new website, press this link to verify your email. And I will be sending my email and through the SES. And I'm using the domain that I already have, and it's a confirmed domain, of course, because it's managed in Route 53, and I already have work mail on it, so I'm kind of using it already. And I will be able to send the welcome email after a user is signed up. Then finally, I have a password policy, and the password policy is just requiring, for example, 12 digits and all these things. And the validity, maybe years, very long, but you can adjust this how you want. This is just a simple setup. You can recover your account by email. You can do also phone or other things. And if you go into production, I would recommend that you put on MFA as well. But for now, we're just going to do email. And finally, we're adding the Lambda trigger, and it's a post confirmation trigger. So after the user has confirmed his sign up, we will trigger this Lambda. It will receive an event from Cognito, and we will process that event, and based on that event we will trigger. And we will also use the KMS key. So we are using a KMS key that will encrypt the password when we are doing it. And again, I have this because after this video I will destroy everything and I don't want it to remain, but in production you should keep it. So that's a really big chunk of the stack. And if you have any questions about it, you can always put it in the comments and I will try to answer it as I can. Then I'm gonna add the Google and Facebook login. And for this, you do need your client secret and your client ID. But as I said, I won't be going through that. So if you do want that, you should go into the description of this video. There's a link, follow the link, and you will have a secret ID and a
client secret in no time. And I stored mine into the secrets manager. That's why I'm able to get it here from the secrets manager. I'm getting the Google secret, which is a prop name. Then I'm creating a Google login. I'm referring to the user pool I want to attach it to. The client ID is the Google client ID. So I'm getting this out of the secret. And because it's not expecting a secret value but a string, I have to unsafe wrap it that I know that I'm actually using it unsafe. But the secret, it is expecting a secret value. And there we just pass in the secret value that's in our secret. The scopes that we will use in this example are profile, email, and OpenID. These are the things that you also need. These are the most basic ones. And then we will also map a couple of the attributes. So as someone uses a Google to log in, we want their email, we want their given name, we want their family name, and we want their birth date. And once we have this identity pool provider, we will just register the user pool with this identity pool provider, and then we will do exactly the same for Facebook. So Facebook, we do exactly the same, just a couple things are different. Instead of the client ID and a secret value, we are using a client ID and a client secret, and the scopes are different. So we're using public profile, email, we're using user birth date, and the attribute mapping is also different. And what I really like about the IntelliSense is that you can just use the enums instead of typing them all out. So just notice that if you're using the Google Federation login, look for the Google email and the Google given name. And when you're doing it for the Facebook one, just use Facebook email and Facebook first name. So that way we have Google and Facebook, but we are not done yet, as this is becoming a really big stack, because once we have the user pool, we have the user pool identity providers, but we also need a user pool client, and that is where we will interact and try to log in. So I will add that as well. So in the user pool client, we have to define a couple things. First, we refer to the user pool that we are creating the client for. Then we will give it a name as well. And you have a lot of options, but in this particular Cognito flow, I will use the OAuth flow. You can also use just password and username, but I want the OAuth flow, and I also want people to log in through Google and Facebook. So we are doing an OAuth flow, and we're gonna authorize we're gonna grant the authorization code, and that code will be then in our URL. So after a user is logged in and he will be redirected to our website, in the URL there will be a code that will grant him, for example, the ability to do the API call or to upload something to the S3 bucket. Then we do need some Cognito scopes. So we are going for, well, phone number is optional, but we do need to have it in our Cognito scopes, even though we have it optional in our other things. We need OpenID for sure, we need email, and we need profile. And if you do need any other things, so just go to the link and go to the scopes that you can add, and based on that you need to maybe add some extra scopes here or maybe remove it. Just know that if you want extra mapping, you might need extra scopes. Then finally we add a dependency on the Google and Facebook login, because we do want to register them here, and he will look for just the login, the identity pools for the Google and the Facebook, and if they are not there, it will fail. So that's why we add a node dependency. That just means that this will wait with the creation until this is done and this is done. So now we have also a user pool client, and we'd also need to have an identity pool, and we're gonna connect this identity pool to our user pool. And so the identity pool that we have, we will give it a name, and we will also allow unauthenticated identities. What this means is that people with and without authentication can call, for example, our API or upload something, but only authenticated users can do certain other actions as well. But for now, we will need to add a user pool client that we want to add as Cognito identity providers, and also the user pool provider name. And these we don't get from the props, but these are from the resources that we're creating. So now that we have that as well, I'm gonna create a couple roles, and I still need to test all these roles, so it might not work perfectly yet, but it will give you an example of how to create these roles. And I don't know if the policies will work yet, so that's the only thing that I have to check yet. But besides that, if you use different policies, it should work perfectly fine. That was again ESLint telling me that I have a way too long file with more than 250 lines. That is a big stack indeed, but let's go over the IAM roles. So I'm creating two roles. I'm creating an authenticated role, and I'm creating an unauthenticated role. And what I'm trying to do here is I'm trying to create two roles that will be assumed by the identities that are authenticating with Cognito, and then I want users to only be able, for example, to put things in their own bucket, or also only retrieve stuff out of their own buckets, but not other buckets. So first I add the role, and it will be assumed by a federation principal, and I add the identity pool reference to it. I will do the same for the unauthenticated role. So it's again assumed by a federation principal, and I just have this out of the documentation. So I cannot explain exactly what everything is doing, but as far as I know, we're saying that the federation login from this identity pool will have if it's not authenticated, we'll assume this role, and if it is authenticated, it will assume this role, and we will do actions based on the roles. So in the next one, we create some statements. So we will give the get bucket, put bucket, and delete object options to the authenticated role, and we will also add the list bucket, and we will enable the condition will be the sub, and a sub is an ID that's created by Cognito. So each user in the Cognito user pool has a sub ID, and the sub ID is like a user ID. So I want the users only to be able to list the buckets and put bucket and get bucket, delete bucket in their own bucket directory. And outside of that, I don't want it to work. So those are the permissions quickly. And for unauthenticated users, I want them to be able to use put object inside of the bucket, but they are not able to list anything, delete anything, or get anything. They can only put stuff in the object, and maybe we can even scope that further, but for now I will just give them the ability to put something in the bucket. Then finally we will attach these roles to the identity pool, and that's just new Cognito and an identity pool role attached, and we will give the reference to the identity pool, and we will give a reference to both of the roles with TRN. So now we also have attached the role to the identity pool, And then we are still not done, as this is a giant stack. And the final steps, that's also again optional. So in the final steps, I will also attach my personal domain to Cognito instead of using the Cognito provided domain. That just means that instead of like AWS and some string, I will use auth.printhelix.com. And for this, you need a certificate. So if you don't want to create a certificate, you can just use the Cognito domain. But I do want to use my own domain, so that's why I created a certificate in US East 1, like I said, and it contains my domain name, so printhelix.com, and it also contains asterisk.printhelix.com, and they are both in my Route 53 DNS records, and A records are from the printhelix, and the asterisk one are both pointing to the same CloudFront distribution. So that's very important, or else this will not work. So to get that in order, we will also create a record for ourselves. And for that, we need to import the hosted zone. And that's what we use the hosted zone ID for. And we need to create an A record for in our hosted zone that will target our domain. So what we are doing is in hosted zone, we will create a new Cognito record with the Cognito domain name. So that's auth.printhelix.com in my case. So it's a subdomain that I'm going to use from my main domain. And then I add a target from alias, and it's a new Route 53 target, and that just targets my domain. And with that, we are at the end of our Cognito stack as well. But we do have a lot of errors. We have a lot of warnings that we need to suppress as well. So I'll just paste them in here, and you can go through them why they are in here. But we don't have MFA, we don't have advanced security mode. We're also using an IAM role with extra permissions, and we're using a wildcard for certain things like these things. I do want to keep these in because I want to give them permissions on everything inside of their bucket, but there are a couple things that you can take out. So do note that these are warnings that we are suppressing, and if you don't want to suppress them, it's maybe the best if you solve them. But into production, I often just try to take most of them out. But as this is a demo, I leave some of them in. So that is the stack. We have the lib and the config. Let's close these off. Then we do need to create another folder. I'm gonna call it source. In that folder, I'll create index.js, and here I will create my new lambda, and I will paste it in, and I'll just go through it, and we'll have a look at what exactly is going on. Let's see. I'll also add this. Okay, so I have a lambda index file, and I also created another folder with some files. I will go through them in a second, but let's start at the index. So I'm creating a lambda function in here, and this is an event that I'm importing from the AWS Lambda types, and it's a post confirmation trigger event. And that's the event that we're expecting inside of this lambda. So that's an event that we will receive from Cognito, and we will handle that inside of here. Besides that, we're going to import CloudWatch client, as we're going to write a metric to CloudWatch whenever we fail to register a user. And with register, I mean we fail to write to either DynamoDB or S3. We need the DynamoDB document client and the DynamoDB client, and an S3 client. Then I have a couple helpers. Those are the files that we have here. I will go through each of them as well. And all the error messages that I will use. So these are just messages of what went wrong. Then I define the clients outside of my code, and I check if they are already there. It's called lazy loading. It just prevents the creation of a new client if there was already a client. As sometimes Lambda gets called recursively and sometimes it just gets called once. So this way you can prevent the client to get created each time that the Lambda runs again. Because else it will create a new client each time you get a new event, and maybe we don't want that. So we will get also the bucket name and the table name from the environment variables, and we were passing these through in the lib. If we go to the lib in the Lambda, we can see that we are passing them through. So the bucket name and table name, we are expecting them here. And if we don't have them, we're gonna throw a new error because they should be there or else the Lambda is not working. And then from the event, so the post confirmation event, we're gonna get a couple of values, and each of these values we will need to write to the DynamoDB table. So, and the sub we will also need for the S3 bucket. So these are in the request attributes. The request user attributes will contain the sub. It will also contain the email verified, given name and family name, but the username is above in a higher object still. So it's in the event.username will contain the username. So that's something to look at. All of the others are event, request, and user attributes. We'll also validate this event. If we are missing any of these values, we will throw an error. But if we do have all of these values, we will try to create a new entry in the customer table, and that will contain an account ID, an account name, account email. If the email was verified already, a given name and a family name. And then we will also create a bucket directory. We will try to create the entry in the DynamoDB table, and if that fails, we will throw an error, and that error will be also posted to CloudWatch. So that is this part. So let's go through the things one by one. So first, the errors. These are just error messages that you can change however you like. Then the bucket action, we are doing a couple things. We're keeping it really simple. So from the AWS SDK, we are getting the put object command, the put object command input and output. I like to do this because that way I can use like IntelliSense to see if anything is missing. So if you're not really familiar with an SDK client, just import the inputs and the outputs. Almost all of the SDK clients have them, and that way you can easily look at which values you need and which values you can add or remove. So what we're going to do is we're going to receive an event, and that event will have a couple things. So it will have the sub, it will have the bucket name, and it will pass in the S3 client. And we're passing the S3 client so that we don't recreate them every time. The sub we will receive out of the event, and the bucket name is from the environment variable. And we will use that to use a put object command. And you probably can use a different command for this as well, but I'm currently using this one because I was familiar with it. And we just create a directory, but we are not actually putting a file in it. So probably you have a better command for this than I'm currently using. But this will be create the input. Here we will create a command, and then we just use the S3. This is like the S3 client .send with the command, and then we check if we have 200 status code. If not, we will throw an error. Same goes for the table. So we will receive a value. It will contain the DynamoDB document client, the table name, from the environment variables, and from the event, the values that we were expecting. We will again make a put command input. Here all the values will be inserted into an object. And then again we create a put command input with this one, and then the DynamoDB client dot send. And we you have to await this, so it is important to await it. Also at the bucket we are awaiting this call, and that means that here we also have to await that call, of course. If they are not returning a 200 code, I will return an error, and if that error is returned, we expect CloudWatch to send a metric. And how does that work? So from CloudWatch client, we're again importing the put command metric and the put command input, and we're expecting the sub, we're expecting the error that occurred, and we're getting the CloudWatch client. Then we create a metric data. So this will create a metric in our account. There's no dashboard to see it yet. We'll create that later. But this will create a metric in our account named field post confirmation metric. We will use the count. It will add a value of 1 with the timestamp of now. And the name again is this name. And this will be the error message. So if we have different error messages, we can maybe sort on the error messages, but it will also contain the error message and then the namespace where it should be. So this metric will be bundled under this namespace. If you have multiple metrics, you can add them on under some namespace. What are we doing? Well, again, it's really simple. We're using CloudWatch client.send, and we are entering the command that we create with new put metric data command. And if that also fails, we just console log error, because then we don't want to stop our run. If it fails to upload, we just console log an error into the logs, and we will get it out of the logs then. So that was the CloudWatch part. And then validate really quick is really simple. I'm just checking if the string is there. If it's not there, we're returning false. And that is the lambda to handle the event. So in this part, because we're using both infrastructure and we're using the lambda test also, let's add some extra test here for the, for the lambda and for the CDK neck. And also let's change construct as well. So let's quickly go through it, but because I already showed it in the previous one, I won't go through in depth through it, but we're just creating a test that expects the lambda to be created. We expect the user pool to be created and what we are expecting in there. So these are the password configs, email, and all that. We're expecting a Facebook and a Google identity pool provider. We're expecting a user pool client. We're expecting an identity pool to be created, and we also expect 2 roles to be created. So those are the tests here. For the CDK neck, again, we just expect no errors, no suppressions or warnings. And for this one, we will do a bit more. So for the lambda, we're gonna import a couple things. So I have a couple fixtures. If you go in there, what are these fixtures? It's just test events. So I'm just creating fake test events, and I'm just adding some dummy data. And from this dummy data, I create different types of events with, for example, the username missing, the email or the sub missing. And all these events will be fired into the code as unit testing, and we expect some responses. So let's go to the lambda test. we import, and this may be interesting because in this project we are using AWS SDK client mock, and what this gives us is just a very easy way to mock all of the SDKs that AWS provides, and with that we can also return some mocked events. We're importing also the clients as we're gonna mock them. Then we're importing all the error messages, all the inputs, all the outputs, and then we mock the clients. So that once these are mocked, you do have to reset them before each. So this just gives you a clean client again. If you have done anything, you just get the client better. And because we are also using environment variables in our Lambda, we also need to pass in the environment variables. So if you don't do this, we get the failure on the unit test that it has no bucket name and no table name, as these are not passed in the environment yet. Then I have a couple tests. Each of the tests just has a description what it exactly does. So successfully creates a S3 directory. What I do here, so I'm mocking the S3 client on the put object, and I'm adding a mock response, and the same goes for the DynamoDB, and I'm just awaiting that it has no error, and from there I just throw an error at each of the missing values. So here, for example, we're missing a table name, the environment variable is not there, and we're expecting an error to be thrown. And if we look at this, it's just the error message that we are missing the environment variables. So that's the way that you can unit test also the Lambda code. So this way we are using this one to test our infrastructure. We are using this to check extra security check, and then we're using Jest also to unit test our Lambda. So I have a couple tests. I won't go through all of them. I was just testing until it was 100%. So if you are curious, you can have a look at the test and see if you like them as well. But for now, let's see if they actually work. So before I do that, I want to do a quick check. Yeah, do have to, of course, add them at the stack config here. So, and I will also change this to be like ph Cognito stack. And I've also added the script commands here as well. So now that I have that, I will run npm run lint. Takes a second, yeah. npm run test. I have two failing tests. Let's see what's exactly failing. Error while sending event. Yeah, yeah, because I have dummy data, it is failing because my bucket ARN is not a valid ARN. So if you do have a valid ARN, these tests should also succeed. I will change my ARN and I will deploy this when it's ready and changed. But just for an extra, I will add a CI/CD pipeline for this as well, using GitHub. So I use mainly GitHub for all of my code. So I'll create a quick folder here, .github. I will create a new file called ci.cml, and wait, I think I have to also create cd.yaml. So if you are using GitHub, GitHub Actions is a really nice way to add a CI/CD workflow for small projects, but also for big projects. So I'll quickly go through it. I have two workflows. They are practically the same, but there are some minor differences. So with the new changes, you cannot echo everything. So that's why I'm using an environment variable to show who is the GitHub actor, so who ran this pipeline. Then I will of course echo that user. We will use GitHub Actions, checkout. Well, if you're really curious about the GitHub Actions, I do have a video that shows exactly how to run this. This is just an updated version of that. But after uploading this to GitHub, it should run a CI/CD workflow that will run the build, it will lint it, it will run the test, and then it will run npm run diff. And npm run diff, as I added the comment, will just check for the difference in the current stack and what is deployed in the cloud. So if we don't have anything, it will show all the components. But if you have already deployed it and you make a change, it will show you the differences of what is deployed. So I think we have the test now as well. I will quickly add my own buckets and config, and then I will show you guys the UI of what we actually created and if the Lambda itself will trigger. So just a second and I will be right back. So I updated my stack config and was able to deploy my stack. And then afterwards I went to the console and under Cognito went to user pools and app integration, went to my app client, and here you can go to the hosted UI, which I will do. And in a later video I will also integrate this into the Next.js app. I won't cover how to create an entire Next.js 13 app. I will cover how to use Cognito and use the authentication there. But for now, I will just use the hosted UI and check if the Lambda that we created is actually working. So here I will sign up. Let's say Faruk. There's also Faruk. And password, let's just do something. And then I will sign up. Okay, it says that I received an email. I will check my email quickly. And I did receive an email with a link which will redirect me to your registration has been confirmed, meaning I can continue here. And now I should be able to log in. Oh. And as you see, I was redirected to print-helix, and I do need the website code here. But we have a code here, meaning that we were authenticated and we received an OAuth code, and we can use this code then to retrieve credentials. And with those credentials, we can make calls, for example, to S3 or to DynamoDB. But at the same time, we also expect that because we signed up, that there should be a user in the user pool, and additionally, we should have So here, as you see, we do have a user called Faruk with my email. And then the next thing that we should look for is that the post sign-up trigger has triggered. And we do see that it was triggered. And as I was expecting, maybe put object is not the right one, but we can change that later. And we expect buckets to be there. And we also expect the DynamoDB entry. So let's see in DynamoDB. So a customer was added to our table. So we can see that the count is 1. It will take a second before it appears here as well. But then also in a bucket, I already opened the bucket, but I have a bucket now with users, and we have a user ID here, which is a directory. And if we look at this user and then go to Cognito, and I open this up, and you can see that it's the sub of the user. So we created an S3 directory with the ID of the sub of the user. And just to quickly show that you can also log in with Google or Facebook, I will first log out. And when you're logging out, for now I will just use this logout link, which is also your subdomain /logout client ID and then the logout URL. So, okay, I'm logged out now. If I go back to the login URL, then let's say that I want to connect with Facebook. It will enable me to log in, and after I log in, I will be there. So I won't log in now, but both Google and Facebook will do exactly the same. And after logging in, you will be able to see the user as well in your user pool, and it will also be have a directory in S3, as well as an entry in the DynamoDB table. And it will just take a second before it appears here. So that was the part for this episode. In the next episode, we will continue on this, and maybe we'll adjust some parts, but we'll build upon this, and we will add an API for doing some extra account pooling and data manipulation. I hope you liked it, and if you are missing anything or you want some extra stuff in it, just leave a comment and I will check if I can edit. Thank you all for watching so far, and have a nice one.